Hey guys, I thought I would make a new video today about mathematics and how you can use mathematics to create shapes and colors and movement and things like that, which is my passion. And because of that, I did some videos before explaining how actual square roots and logarithms work in terms of making lighting and shapes, but I won't do anything like that today. Today I just want to keep it simple and help you understand that by using mathematics in a creative way, you can have fun and do sculpting and lighting and things like that. And for that end, I thought I would create a heart today. A heart, you know, like those cheesy, lovely red hearts that we saw last week during St. Valentine. And I chose that shape because it's pretty easy to make with mathematics, especially if you start with a sphere like the one I have here. So a sphere has a very simple mathematical equation. The equation for this one sphere actually is x squared plus y squared plus z squared equals 15 squared. 15 is the size of the sphere, is the radius, and of course I can make it smaller. I can make it 5 squared, and then it becomes a tiny cute sphere, or I can make it way bigger, like 20 squared, and then it becomes this big sphere. But I'm going to keep it at 15 for today, because that's kind of a good size for this table that I have in front of me right now. So how do we go from a sphere to a heart? The key idea here is that we are going to think of the sphere as if it was made of clay, and we could deform it, and we could push and pull it and give it the shape we wanted. And all those pull and push actions are going to be actually equations that we apply on top of the equation of the sphere, or modifications to the equation of the sphere if you want. And for that to work, the trick here is that the sphere is defined based on the x, y, and z coordinates of a space. It's kind of embedded in space, and you can represent space with a grid. And imagine that now we could deform the grid itself somehow, and then the space inside the grid and the sphere, which was defined in the space of the grid, would be deformed as well. So that's the trick. We are going to be pulling and pushing the space so that the sphere changes the shape until we get what we want, which is a heart. So let's start. The best way to start, I guess, is by taking the sides of the sphere and pulling them up, so we create this kind of shape. And in mathematics, there is a very easy way to describe arcs like that, and that's a parabola, which is a fancy name for a second-degree polynomial, which is actually a fancy name as well for a curve, for the simplest curve that makes an arc, actually. So we can apply that, and what we are going to do is to take the y component of space, which is the vertical component, and subtract a parabola. That is effectively like pulling the space up in the shape of a parabola. And if I do that, this is what I get. But of course, I need this deformation to be symmetric. I want the left and the right hand, left and right side of the heart to be the same. So we are going to be using the absolute value of x, which means that we don't care if x is negative or positive. We do apply the same deformation in both sides. And that's what we get. Of course, there is this 100 factor here, which we can tweak, and because this is not enough of a deformation, so we can make it something like 20 or 15, and 15 looks good. 15 looks a little bit more like a heart. So let's continue working on that until we get the shape we really, really want. So I think the next thing to do would be to make the shape more rounded, the heart a little bit more rounded and cute. And one of the tools we have in order to kind of change the shape of things is the square root. And I have another video where I explain this thing. All you need to know now is that if I apply the square root to the second side of the parabola, well, first, it no longer is a parabola technically, but it kind of helps us shape, as you can see, the heart into something a little bit more rounded and cute. So now we can just squeeze the heart a little bit down by compressing the space by a 20%, by multiplying y by 1.2, and I can add 4 units to kind of move the heart a little bit and make it sit perfectly here on the table. And that pretty much looks like a heart already, a little bit. If I turn it for you and you see it from the side, you will see that still it's a very thick heart, because we did start with the sphere, which was like a 15 units big, or 30 units big actually, and we didn't compress or do anything to the C component. So let's do it. We can multiply C by 2, and then the heart becomes thinner, but we can also do it in a non-uniform way. We can make the bottom thinner and the top thicker, and we can do that by multiplying C by 2 minus y divided by 15. And of course these numbers 15 and 2, I did find them earlier today when I was playing and making the heart, and now I'm just throwing the final results that I found because I didn't want to spend too much time. And that's pretty much it. It looks like a heart to me. What we need is to make it red, I guess. And you can do lighting and color treatment and shadows with mathematics, and that's super fun. But I don't want to stop too much on that today, so I will just make it red. And believe me, I did that with formulas and mathematics. But I want to move to the next topic, which is movement and animation. So let's make the heart move with mathematics, of course. So I guess the first thing we could do is to make the heart beat, and that's very easy. If you think of the original sphere that we had, which was 15 units big, and we could make it smaller and bigger by changing the 15 to other numbers, then if we made it 15 and then 18, then the sphere would be bigger, and all the deformations we applied to it to make it a heart would also become bigger. So we would get effectively a bigger heart. So by changing 15 to 18 and back to 15 and back to 18, we do get a bigger and smaller heart. But of course, instead of making the transition like that from 15 to 18 and make it look like we had two hearts, the small and the big one, it's better if we could smoothly transition from one to the other. Basically convert the 15 into 18 and then back to 15 in a smooth way. And we can do that with the king of the smooth functions, which is the sine wave. And I won't explain what a sine wave is, but basically it is something that goes up and down smoothly and forever. So we can apply that by adding 3 units to the original 15 units that defined the radius of the sphere. And that way we have the heart becoming bigger and smaller smoothly as the sine wave advances over time. We can make it smaller, we can make it faster and slower, but basically that's kind of a beginning or starting point for the animation. And actually the same way we had the first rough shape for the heart and then we made it cuter by shaping it with a square root, we can also shape the movements themselves. We can shape the animation to be more like what we want. We can totally art direct the whole thing if we want so. So in this case, I'm going to shape it again, not with a square root, but with a power function, which in a way it's a related thing to the square root. Square roots are a special case of power functions. So I will be using power 4 to sort of keep the heart small and then spike it very quickly to the size of 18 and then release it very quickly again to become 15 once again before it becomes 18. So basically, once you play for a long time with power functions and square roots, you kind of gain an intuition of what powers do what kind of shaping to the functions. And I know that power 4 makes what I want, which is this more rhythmic movement for the heart. And the last thing I want to do to make it even less mathematical and more organic is to make the animation different at different parts of the heart. Basically, I want some parts of the heart to be expanding while other ones are compressing to make it more like a pumping machine. And we can do that by adding a non-constant phase to the sine wave. Again, it's a very technical word, doesn't matter. Basically, if I add something that depends on y inside the sine wave, then I can change the way the sine wave gets applied to the different parts of the heart. And that way I can create something a little bit more organic like that. And I think this is pretty cool. I think I'm happy with it. I'm sorry I wasn't on time for St. Valentine's to make the video for that date, but that's fine. If you want to learn more about how to make shapes and colors and animals and whatnot with mathematics, you can visit my website, my Twitter, my Facebook, or even my Patreon. And you can even donate some money there if you want for me to allocate more time to make these videos. Like today, I didn't go to work, so I could make this video. So if I want more of that, anything you can do will help me. Other than that, so thanks for watching for now. Bye.